again, as I read this, I want to visualize what's happening over here. And again, assumptions, a nice flat Earth. There's a balloon rising up vertically, and I'll do something like this over here. That's the balloon going up. You get the idea. I'm not going to draw the picture of the balloon, but you get the idea. Balloon's rising from the Earth, and it's going up vertically, all right? So a hot air balloon rising vertically is tracked by an observer located 8 kilometers from liftoff point. So there's an observer over here. This is going to be 8 kilometers, all right? At a certain moment, the angle between the observer line of sight and the horizontal is pi over 5. Now, again, I'm not saying it's a terribly accurate picture, but I'm going to say right now, at some point in time, this observation angle is going to be pi over 5. All right? Okay, so at a certain moment, the angle between the observer's line of sight and the horizontal is pi over 5. Changing at a rate, let's write this down. So what do I know about this over here? This is an angle theta, and they're measuring it, and this angle theta, d theta, dt, is changing at a rate of 0.8. I'm going to write down 8/10, by the way. And that's going to be radians per hour. So really, it's unitless, but I'll write down the RAD, just to remind you that it's unitless, radians per hour. Again, radian, no unit. Okay. Let's see if we can figure this thing out, by the way. So a hot air balloon rising vertically is tracked by an observer located 8 kilometers from liftoff point. At a certain moment, the angle between the observer and the line of sight is pi over 5, changing at a rate blah, blah, blah. It's just x over here. So my question is, do I know the relationship between what I'm seeing over here? And I think I do. I'm going to say it looks like a tangent to me. Tangent theta is going to be x over 8. What am I going to do now? Differentiate both sides. And what do you get? Secant squared theta d theta dt equals 1/8 dx dt. Now what's their question? Their question is, what's dx dt? Let me see, at that particular moment, and what's that moment going to be? At a certain moment, the angles, I'll put this over here, theta is going to be pi over 5. Again, if this thing's rising, this theta is getting bigger and bigger and bigger, all right? And getting bigger and bigger at a rate of 8/10 radians per hour. So let's see if we can figure this out. And again, this is a question. What's your question? Well, let me just multiply both sides by 8. You get 8 secant squared theta d theta dt equals dx dt. Again, I'm not interested in doing the arithmetic, but I will write it down for you. It's going to be 8 times the secant squared. What's theta? Pi over 5. What's the d theta dt? That's 8/10. And what's the unit of this guy over here? Again, maybe you go back and remind yourself. They're talking about kilometers per hour. Put this over here. And this is going to be dx dt. Again, I'm not interested in doing the arithmetic, but I bet in the notes the arithmetic is being done for us. Let's see if we got it written down, by the way. And I'm looking at it. And what do I see? I do see 8. By the way, cosine squared on the bottom is the same thing as secant squared. So it's going to be, pi over 5, and then 0.8, and the unit of that is going to be kilometers per hour. Again, they approximated for me, and you can do that too with a handout calculator or using computer algebra system. Thank you.